Have you ever wondered how to measure the specific heat of various metals? Of course you have. So sit down, prepare your materials. You'll need your copybook ready, a pencil, and a calculator. Also, be sure to have the textbook that accompanies the series ready, as you may need it for reference. The equipment you'll need for today's experiment will be masses of various sizes. A balance, a graduated cylinder for measuring liquids, and a calculator to assist in making calculations. You'll need to have a pot of boiling water to heat up your metals. Be sure to notice the heat. You'll also need a digital thermometer and a liquid containment vessel. The metals we're using for today's experiment are iron, copper, aluminum, and brass. Next, you will need to find the mass of each of your metals. Now that that's done, let's discuss the formula we will be using to find the specific heat of our metals. In this formula, M equals the mass, S the specific heat, and delta T is the change in temperature. This equation works because of the law of conservation of energy. In an isolated chamber, all the energy that escapes the hot metal will be transferred into the surrounding water. Thus, energy is conserved. Now we're ready to begin the experiment. You'll need your liquid containment vessel. We're using styrofoam. Note the insulated property of styrofoam. Now, transfer your known quantity of water. Seal with your insulated lid. The hole in the middle is for the thermometer, which you'll want to place through the hole into the water. You'll then want to record the initial temperature of the water. Recall the boiling water from earlier. Safety is a must when handling boiling solvents, such as water. Carefully transfer your hot metal to the water in your isolated chamber. Now we wait. Periodic agitation of the water is essential, as the water closest to the metal will be warmer than the outside water. We allowed for about 10 minutes of total time needed for the water and the metal to reach an equilibrium. One last agitation at the end for good measure. When recording your temperature changes, your data should look something like this. Now, let's plug in our numbers for an equation looking at the specific heat of iron. When solving for S, you get a specific heat value for iron of 493.76 joules per kilogram degree Celsius. Let's see how we did. We got our experimental value subtracted by the known value, divided by the known value, times 100, and our percent error is 7.34%. When finding the specific heat of the other metals, you will run the exact same experiment in a similar fashion, substituting for the other metals. Here was our findings. Not too shabby.
You know our love was meant to be the kind of love to last forever, and I want you here with me.